Okay, we have learned the difference between chemical change and physical change. Physical change is a temporary change, it can be always what? Reversible, okay? But chemical change, 99% of them are permanent change, it is not easily reversible. Okay, so during a chemical change, we will start with the chemicals, those are called what? Reactants. The starting chemicals are called reactants. So the reactants are converting into the final compound. We call them what? Products. So there will be only two things: reactants, which is before the reaction, and products, which is after the reaction. So whenever you do or whenever you see a change, this is how we are going to identify whether it is a chemical change or physical change. The first one, if there is a production of heat, that means if there is a temperature change of the ingredient or surroundings, that is an indication, okay? Or if we see a light, remember yesterday we did the demo, you see a light, okay? That means that is a chemical change. Then another one, color change. Okay, if you are mixing yellow with green and you are getting a purple color or something like that, unexpected color change, okay? Or smell, we'll say odor change in smell. Or if you are seeing bubbling, that means there is gas producing. Bubbles or gas is also an indication of chemical change. Then the last one is, we have seen that in our previous lab, which is a formation of a solid substance called precipitate. So whenever you see one of this, we don't need to everything happen in a single reaction. If there is any one of this happen, we will say that is what? A chemical change. And think about some real life examples of chemical reaction, and you have to write that there. Okay, here you can see a chemical reaction given here. So the chemicals in red color, those are the starting chemical, and we will call them what? Reactants. Okay, and this one is what? Products. And these numbers, like numbers like as a bottom, we will call them what? Subscript. Okay, subscript tells you how many atoms are there. But this purple number, that is on the left hand side of each compound or molecule or element, which is called coefficient. So coefficient tells us how many total of that one is there, not just one element, okay? If there is a big molecule, all the atoms will be doubling or tripling based on the coefficients. So this is the only one we can change while during balancing, okay? And this is called arrow, will shows the direction of the reaction, or it will read it yield or produce or gives. You can use all terminology for interpreting that one, okay? Now reaction symbols. So whenever you write the reactants, we will see lot of symbols. If you are seeing S there, that means it is a solid. Look at the periodic table, everything in black and white color printed, those are solids. And liquids, everything in blue, there are two, there is mercury and bromine, that is called what? Liquid. And if they are red color, they are called what? Gases. And among gases, there are some diatomic, remember hydrogen and others, 7 elements, they are diatomic. Aqueous means, we have seen that in the previous lab, something which is dissolved in water is called aqueous, Aqueous. And RXN is the abbreviation of reaction. NR means there is no reaction. And if you see this symbol, we already saw that it's called arrow. It shows gives, produce, or yield. And if we say a symbol like this, it's like a double-headed arrow. That is called, that reaction is reversible when we can change from product to reactant. Okay, reversible reactions, say one example is in our mobile battery or computer battery. When the charge is down, we can recharge it. Okay, they are using a reversible chemical reaction. Okay, that is the basic stuff you need to know. Okay, so now we are going to start writing the equation from a sentence. Okay, it says solid barium reacts with oxygen to produce barium oxide. Okay, so for writing that, we need to know a couple of things. First one, diatomic elements. I said 7 elements including hydrogen, then starting from nitrogen, they all exist as diatomic. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All these elements, whenever you write them, you have to write that with the 2 there. Okay, they are called diatomic. Okay, here barium is a metal and oxygen is a non-metal. So what type of compound they will make? Ionic or covalent?
Wait, barium.
Barium is a metal, oxygen is a non-metal. Metal and non-metal will make what type of compound? Ionic. So this is an ionic compound. The product will be an ionic compound. What is the formula of this product? It says barium oxide. Barium is in 2nd group, oxygen is in 16th group. So look at the charges. Barium has a charge of 2, oxygen has a charge of 2. So we can simplify. So the formula will be BaO. Okay, and the order always matter, yes, because you have to write the metal first, then non-metal. If there are 2 non-metals, we will follow the order in the periodic table, okay? Hydrogen is always an exception. Okay, let's start. Solid barium. You will go write the symbol of barium. And it says solid, so we will write an S as a subscript because it is solid. And oxygen gas, we know that oxygen is diatomic, so you will write O2. And it says gas, so write G as a subscript. Then what is the product here? Barium oxide, and it also said it is a solid, so we can write solid there. Good? Okay, let's go write one more example, then rest you can do as a homework, okay? It says solid potassium chlorate. Write the formula. Potassium is +1, chlorate is -1. Crisscross them. Chlorate, it is a polyatomic ion. What is it? ClO3. So KClO3. And it is a solid. Okay, and decomposes, that means it breaking down, there is no other reactant. Okay, we learned a decomposition. You didn't learn that. Yeah, you guys learned that. So decompose to produce what? Oxygen gas. So you'll write O2 gas plus KCl, potassium chloride, and say solid. Okay, this is how we are writing the skeleton equation. Okay, you will have, I think, 1, 2, 3, 4, 5, 6, 7 questions for writing the skeleton and balancing and identifying. Potassium chloride gives O2 plus KCl. Okay, now skipping all of this and going to the law of conservation of mass. This law says, law of conservation of mass. It states that mass cannot be created or destroyed. That means the number of atoms from left hand side must be equal to what? Right hand side. If it is not, you have to make them equal. That processing is called balancing. That means making atoms equal on both sides. Okay, let's look at this equation. So this is a basic of balancing, okay? First, As a beginner, you always draw a T-chart and write and list them. Once you understand, you don't need to do that, okay? So how many barium are there in the left-hand side? Left-hand sides are called reactants and right-hand side is called product. So there is one barium in the left-hand side and one, look at this one barium in the right-hand side. And oxygen, how many here? 2. And on the right-hand side, there is only 1. Okay, so that means oxygen is not equal. So we are not allowed to change the subscript. You can only add coefficient on the left-hand side. So what I'm going to do, I'm not answering all this. Okay, what I'm going to do, this is 1 and 2, 1 and 1. I'm going to multiply whatever the element, whatever the compound which has O in it, I'm going to multiply that with the 2. Okay, so if you multiply this with the 2, what happened? Oxygen is equal now. What happened to the barium?
2.
Barium become 2. So barium is also got multiplied into 2. So we have to make left-hand side the same number, okay? So I'm going to multiply that with what? 2. So we will go here and multiply this with the 2. Because barium needed 2, so I multiplied that with the 2. So now look at this. This has 2 barium, okay? Barium is balanced. Thank you. Barium is balanced. Oxygen is 2 and there is oxygen is 2. Everything is balanced. You understand? Okay. Okay, so the rules about the balancing, okay? Okay, so the rules about the balancing, we will never change what? Subscripts. We are not allowed to touch the subscripts. We know that the subscripts are coming from crisscrossing. There is a reason for subscripts. Coefficients are the numbers we can change it. We will change them by multiplying with the whole number. No fractions allowed. Okay. Okay. Now let's go practice the next one. It says hydrogen gas react with oxygen gas to form water. So hydrogen gas, how will you write hydrogen? H2. And it says gas plus oxygen gas and form water. What is the state of water? Liquid. So you can write L. Okay, now we have an equation. So we'll start the T-chart. It's not a T-chart. I don't know, whatever you call. Reactants and products. Okay, hydrogen, list them. Hydrogen is 2 here on the left hand side and right hand side is also 2. Oxygen, 2 on the left hand side and how many on the right hand side? 1. Okay, which one is not balanced? Oxygen. Okay, so we'll do what? Multiply with the 2. So you cannot multiply the single element because it is 1 instant, okay? You can multiply only here. So I'm going to multiply here with the 2. What happened now? Oxygen is balanced, but there is a problem there now. Hydrogen is 4. Hydrogen is also got multiplied. So I have to make the hydrogen equal on the left-hand side by multiplying with what? 2. Understand? Yeah. Okay, now let's do the difficult one. Okay, I'm skipping all the simple ones. You can do that as a homework once you learned everything. Okay, so let's go to this one, which is polyatomic ion. I think it will be next page. Okay, ready? Okay, it says silver nitrate. Silver nitrate reacts with copper, form copper 2 nitrate and solid silver. Okay, so you have to write the formula first. Silver nitrate AgNO3 plus Cu, solid Cu. Copper 2 nitrate is CuNO3 2 times plus silver. Okay, now let's look at the T chart. Okay, only one rule I'm going to teach you here. It's not a rule, it's a tip, okay? If you see polyatomic ion, there is NO3 here and NO3 here. There are polyatomic ions, same polyatomic ion on both sides. We will consider them as a single unit. Okay, that means whenever you list them, I'm going to list, okay, there is Ag. Instead of nitrogen and oxygen, I will keep that as a single thing. So that will save a lot of time, okay? Then Cu. Okay, let's go find the atom. Silver, one on the left, one on the right. Nitrate, how many? One, and no, this is just one, okay? NO3 is one thing. And here how many? Look at the number, 2. And copper is 1, copper is 1. So except nitrate, everything is balanced. So what I'm going to do, I will multiply whatever the compound has nitrate with what? 2. So we will go here and multiply with the 2. So that changed another atom which is connected to nitrate, which is Ag. Ag also automatically changed into 2. Okay, so here Ag is only 1. I need to make that into 2 by multiplying with the 2. Okay, so everything is balanced.
What about this one?
The combustion one?
No, what some of these? Because like PO.
Yeah, so there is no polyatomic ion. You can see polyatomic ion here, but there is no polyatomic ion on the right hand side. So you have to list each atoms, like hydrogen separately, phosphorus separately, oxygen.
But if they're on both sides.
Yeah,
then-
if they are same on both sides, we can
Okay.
split, consider as a single unit. Okay, do one more before we go learn the next type. One more, do this. So try. Do the number 2. Number 1 is easy. 2, do 2. Okay, already equation is given to you. What are you going to do first? List them, okay? Reactant products. Okay. Did you see a polyatomic ion unchanged then both sides? Yes. There is phosphate here, phosphate here. Okay, list everything. First one is Ba, then Cl. The order doesn't matter. You can do in any order, okay? I always follow this order, but you know, that up to you. Always follow metal, non-metal order. That will help you a little bit, but okay, so Ba, how many here on the left hand side? 1 and 3 on the right hand side, okay. Chlorine 2 and 1 on the right hand side, and sodium 3, and here there is how many? 1. Phosphate 1, and look, for polyatomic ion you have to look at the subscripts, okay, the number outside, which is 2. Okay, so now we are going to do balance the balance the element. There is 1 Ba here, 3 Ba here, and you are going to multiply with what? 3. So I am going to multiply this with the 3. So what happened to chlorine? 3 times 2 become 6. So chlorine is 6. I have to make this into 6 by multiplying with the 6. That changed what here? What is connected to chlorine here? Sodium. We have progress check today.
Okay.
Yeah. So 6 sodium, we will multiply, sodium becomes 6, so you will multiply here with what?
6.
No, this is already 3. We have to multiply only with what? 2. So that change phosphate into what? 2, and phosphate is already 2 here.